questions from homeworks if you guys have any. So I think at this point we've assigned like up to, I don't know, like 18 or 20 or something like that.
You only made it to 12. 11 and 12 is what you said this last.
No, I not for the, oh. Okay.
11 and 12.
All right. That's okay. That's fair. Yeah, so that's right. Does anyone have any questions on any of those things? All right, easy enough. If you change your mind, we can always come back and, we'll have a chance at the start of really every class for that kind of thing. So no big deal. I think last time we had covered we finished section 1, 2, and we covered section 1, 3. Does that sound right?
We talked about
Continuities, yeah. You know what? Like, everybody's a critic, huh?
I'm just trying to help throw it out.
All right. We're going to do sections 1.4, 1.5, and probably start 1.6 today. So today we're going to be talking about intervals of increasing, decreasing, and constant, as well as extrema. So I'm going to really kind of informally define increasing, decreasing, and constant. These things are adjectives that we use to describe a function. So let's say we have some function. It's going like this. I guess I can put like an XY axis in here or something. Okay, so we have some function. If we imagine that there's like a little person that's walking along our function from left to right, when that person is walking uphill, that is where the function is increasing. When your little person is walking along flat ground, that's where that function is constant. And where that little person is walking downhill, that's where the function is decreasing. Is everybody okay with those descriptions? So you just imagine your little person walking along your graph. Thing to remember is we're always talking about that little person walking from left to right. So the direction that they're walking is always from the left side of your graph to the right side of your graph. So let's imagine this is the point, say 4, 2. Maybe this one will be 8, 2. So if we wanted to write down the interval over which this person is walking, we're going to describe that using the x-coordinates. So if I want the intervals where we are increasing, constant, and decreasing, I'm going to locate my increasing interval, which is the piece that is in yellow. And I'm going to locate the far left end of it, which is like here. And I'm going to read the x-coordinate from that end. Uh-oh, there's no x-coordinate written here. But what is really going on with that end? Yeah, since it's the left end and it's pointing down, it's like the point negative infinity, comma negative infinity. The negative infinity in the left is because the arrow is pointing to the left. And the negative infinity in the y component is because the arrow is pointing down. right? So my interval for increasing goes from negative infinity to negative 4. And since these are x coordinates, I'd write it that way. Everybody okay with that? So now, if I look at my interval of constant, the furthest point to the left on my interval that's constant is the point 4, 2. And the furthest point to the right on that interval that's constant is 8, 2. So my interval of constant goes from 4 to 8. Does everybody feel okay there? Now I'll do my interval decreasing. So my interval decreasing starts at the point 8, 2. That's the point to the furthest left. But the point on the furthest right, oh no, there's nothing written there. Well, that point would be like positive infinity because it's pointing to the right, and negative infinity because the arrow is pointing down. So my interval decreasing starts at 8 and ends at positive infinity. You guys feel okay doing this? Notice a couple of observations here. All of the endpoints on these intervals are parentheses. That'll be the case for all intervals of increasing, decreasing, and constant. They're always going to be parentheses rather than brackets. So that's nice, right? Whenever it's always, I don't have to remember like, oh, is there some like weird rule about this? No. The way we're going to define increasing, decreasing, and constant means that they're always just going to have parentheses. Everybody's cool with that? Okay. You feel good about doing these intervals increasing, decreasing, and constant? Keep in mind, this example we looked at had only one of each type. Does that need to be the case? Could you have more than one?
Yes.
Yeah, right? So you just have to be a little bit careful. If you have more than one interval, what symbol do you use to hook those intervals together?
U.
That U symbol. Yep. Good. All right, so let's talk about extrema next then. So there are two types of extrema. There's maxima. That's just the plural for the word maximum. And then there's minima. That's just the plural for the word minimum. Everybody's okay with that? Now there's two types of maxima and two types of minima. There's local maximum or maxima and minima, and then there's global, or I think some of you guys use the word absolute. Depends on the textbook or your teacher. I'm going to use the term global, but you could use absolute interchangeably. So a global max or min is the overall highest or lowest point. And a local maximum or minimum is the highest or lowest point in its neighborhood. So let's look at a couple of pictures here to kind of get used to that definition, or these definitions. Sound okay to you guys? Okay. We'll sketch a little XY axis in here. Oh, and then my pen stopped working midway. All right. How many extrema do you guys see here? Should see 3, right? I see one here, and then one there. Does everybody agree with that? Okay. Let's say that this is the point -4, 2. Maybe this is the point -1, -2. And let's maybe make this the point 3, 4. All right. -4, 2. Is that a maximum or minimum? That's a maximum. And is that local or global? That is local, right? How can you tell it's not global? Well, there's other points that are higher than it, right? Great. Okay. How about -1, -2? Is that a maximum or minimum? Minimum. Okay. And is that local or global? Local. Why is it not global?
Because it's the lowest point.
It's not the lowest point. Yeah, the arrows pointing down contain points lower than that one, right? Even though it may not look like it in our picture, the arrows pointing down, we know, go on forever. So in this one, there is no global minimum, because the arrow, any point you pick, even on that arrow, because the arrow goes on forever, there's another point after it that's lower. Does that feel okay there? All right. 3, 4 then is max or min? That's a maximum. And then it's local or global? Global. That is the highest overall point. Does everybody feel good on doing that? Do you guys, yes, Boyd.
Couldn't there be higher points that we don't know of? Or is it just like this?
Well, once you've put the arrow on, you assume the arrow is just doing the same thing. It's just going straight down forever. Does that make sense? Okay. So like once the arrows are pointing down, it just means it's going down forever. It's not going to like, oh, and it loops back up and goes higher. We draw the part of the graph that like, and after it stops doing anything different, you can just put an arrow at the end where it's just going to go. You know what I mean? But that's a fair question. Do you guys notice a relationship between the locations of these maxima or minima and the boundaries for our intervals of increasing and decreasing? Boyd?
They're like the points where something changes direction.
Yeah, so the maxima and minima are the points where the graph changes from increasing to decreasing or decreasing to increasing, right? So if we look at this, I notice that the graph is increasing there, and then we're decreasing there. Does everybody see that? So if I wanted to write my interval for increasing, how would I write that increasing interval? Negative infinity, negative 4. And then give it a u. Negative 1 to 3. Everybody cool with that? That this is like negative infinity over here. So we're just going x to x, and then x to x. How about the intervals of decreasing? You would have probably done it at the very start of the year. So if you forgot it from last year, that's probably why. It would have been in the first 2 weeks or so. I bet you would have done this. So for the decreasing, negative 4 to negative 1. Yep. Very good. Again, this point at the far left is like positive infinity comma negative infinity. So we're going from negative 4 to negative 1, and then 3 to positive infinity. So again, fairly easy, right? To do this once you have if you have the picture. What if we do it this way? If I ask you to find and classify the extrema for and then I give you an equation, but no graph. Sure, yeah. You want to start by typing it into your calculator? That sounds like a reasonable first step. Use this symbol above the division sign to make an exponent. Oh. All right. Once we've got that typed in, I'm going to graph it. I'm going to press Zoom Standard, though, because I use the calculator in like all these different classes I teach, so who knows what the window was when I turned it off last. So I just, usually the first time I just Zoom Standard and said hit graph so that it takes me back to a reasonable size window. So here's our graph. When I look at this, what do you guys see? What extrema do we see?
We got a minimum, a maximum, and another minimum.
Okay. And then are they local or globals?
Well, we got one global, and then that's a local, and another local.
Everybody agree? Because is that the lowest overall point on the graph? Because both the ends are pointing up. There's nothing lower than that. Does that feel good? Nope, because all of this stuff is higher. Yep. All right. So what if I asked for the coordinates of these points? So we're going to do second trace. And which command am I going to use?
Minimum.
I'm going to use the minimum and maximum commands. I'm going to do that global minimum first. So I'm going to pick the minimum command.
Wait, how do you get to that?
Second, and then trace. The second button's the blue one, and trace is up there on that top row of buttons. So when I'm doing minimum first. When I select either the minimum or maximum command, the calculator is going to ask me 3 questions that I need to answer for it to tell me what the minimum or maximum is. So notice at the bottom of my screen it now says left bound with a question mark, and my cursor is shown up on the screen. What the left bound with a question mark is asking me to do is to move my cursor somewhere to the left of the minimum I'm looking for. So if my minimum I'm looking for is right here where my cursor is, I'm just going to move my calculator cursor somewhere where it's over here on the left side of it. Doesn't really matter where, so that's good. I'll press enter. Then it asks for a right bound. So again, I'm going to move my calculator cursor somewhere so it's over here on the right side of it. Doesn't really matter where. That looks good there. I'll press enter again. And now it asks for a guess. The guess, as long as there's only one, like in this case, minimum in between my left bound and my right bound, the guess doesn't matter. So I'm just going to press enter again. And there is my minimum. So if Mr. Kulik doesn't tell you how many decimal points should you give?
I probably do 2.
All of them.
Every single one of them? You want to add every one? Every one of them?
More than likely on a quiz or a test on a problem like this, I would ask for like 4 or 5 decimal places. Why would I ask you for that much?
You want the exact number?
To make sure that you're able to use the calculator max and min function rather than just hitting trace on your calculator and moving it somewhere close and reading that number off.
I see.
Okay?
So we list.
So if I don't tell you on something like this, I would list them all. But I mean, I would tell you, and it'll be a lot. So that you can't just like be on the screen, press the trace button, go, oh, I'll just kind of move my cursor somewhere there, and yeah, that looks good, and write down the number, because it won't be the same. You know what I mean?
Yeah.
It's just a way to make sure that you're using the calculator function. I know you wouldn't, but I'm telling you why I'm asking for that many decimal points, which seems like an absurd number of decimal points, right? And I wouldn't ask you for that much on like just like a regular old problem.
Yeah, good job.
All right, trying to find the local maximum now using that same command on your calculator. Follow along. See if you can get the correct value. Fellas, if the food's going to become like this smorgasbord thing that's going to be kind of a noisy distraction for me, I'm going to ask you not to eat in class. If you can continue to do so quietly without throwing food across the room and like crinkling wrappers incessantly, it's no big deal. So if we can just kind of ring that in a little bit, I would appreciate it. Okay? Again, it's hard for me to hear and talk over myself and concentrate. I imagine it is for other people too. And I don't mind you eating, but it's the noise that goes along with it that was becoming an issue. Okay? All right. I'm finding the other maximum. You guys should be trying to follow along and see if you can get the same value that's about to come out of my calculator.
How do you get back to the graph after?
If you just press the graph button on the far right of the top row, that'll do it. So I got about negative 3.16 comma 1.495. Again, I rounded that to 3 decimal places because I just didn't want to read all the numbers. If you did it correctly, you should have gotten, that would have been enough to tell you, like, oh, yep, did it. I'm a calculator all-star. Do you guys remember doing this on your calculator last year? Did your teacher show you how to do this and you guys did this? Excellent.
Yep.
Excellent. Okay. Any questions on increasing, decreasing constant or extrema? Fairly easy concepts, right? Their names kind of sound what they are. That's really helpful. There's no computation to find these things. Pretty helpful, just kind of remembering what the names mean, but the names are pretty obvious, right? About which is which. Okay. Next up, we're going to be... That was all 1.4. That was it. The next topic we're going to talk about is symmetry. And there's going to be 3 types of symmetries that we'll talk about. The first type is going to be symmetry with respect to the x-axis. I abbreviate the phrase with respect to as WRT, as that phrase comes up not infrequently in a math classroom. It's a fairly commonly used abbreviation. WRT is with respect to. So here is an example of the graph of a function that is symmetric with respect to the x-axis. What you should notice here is if you take the portion of the graph that's below the x-axis and you reflect it across the x-axis, it would be exactly the part of the graph that's above the x-axis, right? That the 2 halves of our graph are mirror images of one another. Does everybody feel okay there? So, for example, if this is the point A comma f of A, this point down here would be the point A comma negative f of A. Assuming that this is the graph y equals f of x, of course. Everybody's good there? Okay. So what that means algebraically is then that f of x should also give me negative f of x. Okay. So if I have symmetry with respect to the x-axis, what other type of symmetry do you think we have?
Y.
Yes. Okay. So what's that picture going to look like? So here's an example. Again, notice if I take the part of the graph that's on the left side of the y-axis, reflect it across the y-axis, it's going to give me exactly the part of the graph on the right side of the y-axis. Does that feel okay? So if this point here is the point A comma f of A, this point over here has to be then negative A comma f of A. You guys agree with that?
Yes.
So what I can say then is that f of negative x has to equal f of x. This type of symmetry gets a special name. Functions that have this type of symmetry are called even functions. Everybody's okay with this so far? Do you guys remember these terms from geometry? I think you talk about these types of symmetries in geometry. Although that was a long time ago, so if you're like, yeah, did we? That's okay, not uncommon. Anybody remember or have a guess as to what the third kind is going to be? No. Okay, well, it's called 180-degree point symmetry with respect to the origin Oh boy, Mr. Kulik, that's a mouthful. What the heck does that look like? It's really no big deal. So this is an example of what that would look like. Notice that if I take the part that's left of the x-axis and I reflect it across the x-axis and then take that part and reflect it across the y-axis, I get exactly the other part of the graph. And the order in which I did that doesn't actually really matter. I could have reflected across the y first and then the x. But either way, you're going to get the same thing. Does that feel okay to everybody? So again, if this is the point A comma f of A, I would also have the point negative A, negative f of A, which tells me algebraically what I have is that f of negative x has to equal negative f of x. Functions with this symmetry also get a special name. These are called odd functions. How come that first type we talked about, how come that didn't get a special name? It's not a function, right? Is that going to come up for us if we mostly talk about functions? Not really, right? Not really. Okay, is everybody so far so good? All right. So, next up, example. All right. So let's say that we want to show that a function is even, odd, or neither. The first thing that I'd want to do is to look at the graph so I can tell which one of these three I should be shooting for. Everybody cool with that plan? So let's go ahead and just type that first feller in. We're going to do 4 of these examples, just FYI. That's why I said the first guy, even though there's only one thing written so far. And you're like, it's the only thing I've written down, Mr. Kulik. What do you mean first? Well, it's getting ahead of myself. So if I look at this, what do you see? So odd, even, or neither, though. This is an even one. Everybody agree that it matched the pictures that we kind of drew and talked about for evens? So to show something is even, I need to show this. Oops. That f of negative x equals f of x. Everybody's okay with that idea? To show something algebraic like this, what I'm going to do is I'm going to start with the left-hand side and try to end with the right-hand side. Yes, Boyd.
What does WTS mean?
Oh, what does WTS mean? I didn't say it, did I? It's an abbreviation. Well, that was WRT.
Oh, just kidding.
That's okay. WST is an abbreviation for the phrase want to show. Since it says show that this thing is even, or we're trying to show it's even. If I can do that, that's part of my definition of things being even. Don't you just stab your friend in the head? Okay. All right. So I have a question for you. We have this function up here, f of x. If I did f of 2, what would that mean?
You'd have to plug in
You'd
two.
have to substitute.
We'd have to, great, we'd have to plug 2 in for x, right? And evaluate? Everybody agree? If I did f of negative 6, what would I do?
Same thing.
Plug negative 6 in. What if I did f of a?
Oh, A is equal to -1.
No, man, I just plug a in. Just plug a in for x, right? Everybody agree?
No.
No?
Wait, no, I was getting negative
You know, I know coefficient.
If I was doing f of a, I would just plug a in for x, right?
Yeah.
What if I'm doing f of negative x?
Then same thing.
Plug negative x in for x, right?
Yes.
So if I do that, I'm going to have negative x to the 4th plus 1. I've just plugged negative x in for x. Everybody's okay with what I did there? So now let's simplify. So negative x to the 4th really means negative x times negative x times negative x times negative x. How many negatives are we multiplying together? If I multiply 4 negatives, what do I get? Positive. And if I multiply then 4 x's together, I get x to the 4th. Does everybody feel okay with how I simplified that? Okay. If I look at this and I look at this, what do you notice?
Exactly.
They're the exact same. So this is equal to f of x. So what have I shown?
That is even solution.
F of negative x equals f of x, which is what I wanted to do. I'm done. Yes.
So if it was like to the power of 3, the x,
Mm-hmm.
would you just put like odd function, or would you like try to like solve that, or could you do that?
Well, let's look at the next example. Is that will this example do it for you? All
Yeah.
right, let's do that next. So what do I do to start? Plug it into my calculator and look at the picture. So what do you notice here?
The origin.
That looks odd, right?
Yes.
Everybody good with that? Agree that we saw odd?
Yes.
So what do we want to show there? f of negative x is equal to negative f of x. Okay? Again, this was just my algebraic definition for an odd function that we just mentioned a moment ago. And oops, why am I using f's here though? Let's be consistent, Mr. Kulik. Right? This function I call g of x. Let's just not confuse the bejesus out of everybody and just use the same letter all the way through. Does that feel okay? All right. Oops. You're writing in pens? Oh, those thieves. They probably hawking it on the black market right now. That's a guilty man's laugh right there is what that is. All right. So just like the previous one, we need to start with g of negative x. What does that mean? We're just plugging negative x into our function, right? Is everybody happy with what I did? Okay. Negative x to the third means negative x times negative x times negative x. Three negatives multiplied together is?
Negative.
Okay. And then x times x times x is? X to the third. And x to the third times 2 is? 2x to the third. It's kind of surprising that nobody wanted to answer that piece. It was like the easiest part, but okay. I may have been talking a little too fast. That happens sometimes. All right. And then what's 3 times negative x? Negative 3x. Everybody's cool so far? And I'm trying to get to negative g of x. So let's start by factoring a negative sign off next. When I factor a negative off, everything that was negative now becomes positive, and everything that was positive would then become negative. Is everybody okay there? Mm-hmm. Yep. And what do I notice now? That is the same. So I still have that negative sign out front, and that is g of x, which is exactly what I was trying to get to. We're done. Everybody okay with what we've done so far?
Yeah.
Okay.
Yeah, exactly.
Time for the third example. What do you suppose is going to happen for this one? What does your student instinct tell you this example should be?
Number one.
I think it's gonna be neither.
It should be neither, right?
Yeah.
If your teacher gives you an example where it's one of 3 things and you're doing 3 examples, probably you're going to get one of each of 3 things happen, right? At least if your teacher's doing good teaching, you know. All right. Well, let's look at the picture anyways, even though we have our student instinct tells us what we think is going to happen here. Okay. So there we go. Typed it in. I'll hit graph. That's not a very good picture, huh?
You gotta zoom in.
Got a little piece right here.
You gotta scoot the graph up.
Zoom in.
Yeah. Which way do I need to move the graph to see? Needs to go up,
Northbound.
right? So Up is moving in which, or involves which coordinate?
Y.
Y.
The positive Y.
Okay. And is it going to be the Y mins or the Y maxes?
Y max.
So I'm just going to change that Y max to be a bigger number. Maybe let's do 30. You can, but I like to pick what I'm doing because sometimes Zoom Fit gives you what they think you want. I like to know what I want. I press the window button to pick. And after I changed, I hit graph. If you look at this, what is this?
Oh, that is a
Even.
It is not even. Why isn't it even?
Oh wait, no, it doesn't.
Not because
It's
It's not got.
It's not symmetrical.
Yes.
Yeah.
Half of it's not on each side, right? There's more a parabola on the right side than there is the left side. So this is neither, as we thought, although it's a little bit tricky because it's close. All right. What do I have to do to show something is neither?
Let me check. F of x equals negative f of x.
Well, nope. We have to show that it's not even, and we have to show that it's not odd. Is everybody okay with that? All right. Notice here that to do even or odd, we're both starting with h of negative x, right? So I can actually do both of these kind of at the same time. So we'll just start with h of negative x. What do I get when I do h of negative x? What do I get?
Negative or 4 negative x minus 3x negative x plus.
Everybody okay with this? Some of us, I think, we're simplifying at the same time. I'm just was trying to write down just the substitution first, just so that we're all on the same page. Wouldn't be wrong to skip that step and go right to the simplified if you can do that, but not everybody can. And since they're notes, I don't try not to skip a lot of steps when we're doing something, especially that is not a familiar skill that we're doing right now. This is not something you've probably done a lot of practice already. If we're solving like a linear equation or something, I'd be skipping steps all over the place after doing one or two thoroughly. But this is new, right? Okay, negative x squared. What do I get when I simplify that? X squared, right? So that just becomes 4x squared to start. Negative 3 times negative x is
Plus 3x.
And then the plus 9 just stays the way it is. If I look at this, and I compare it to h of x, are they the same?
Oh no.
Nope. So that's not equal to h of x, so I know it's not even. And then let's keep going. To check if it's odd, I'm going to factor off that negative sign again. When I factor off the negative sign, all these positive things become negative, and any negative things would become positive. And if I look at this and compare it to the original, are they the same? No. So this is not negative h of x. So it's not odd either. So we're done. Because we've shown now it's not even and it's not odd. Do you like how I did that where I just had like a little exit ramp, like here's the even part, not that. Here's the odd part, not that. Rather than doing it as two separate lines. You could do it as two separate lines, but like you're just recopying a lot of stuff. It's not wrong to do it that way. Just Mr. Kulik's efficient. I want to save all that pencil lead. Because I'm definitely all my digital pencil lead.
How's the computer working?
Today it's been pretty well behaved. We'll see. It's early.
It's been tamed.
Well, I did the big Windows cumulative update yesterday, or this morning, and that might have helped. Apparently there was a Windows update that got published yesterday or so. So you might want to, if you haven't done that yet, you might want to do that. That seemed like it helped out my computer a little bit. Okay. All right. That's it for symmetry. Next thing we're going to be talking about are asymptotes. Yup.
That's a fun word.
Yup.
Oh.
So
It's a good.
No, yeah.
what is an asymptote? This is something that ideally you would have talked about in your Algebra 2 class, although I don't believe that was the case for you guys.
I don't.
Oh, done. Oh, she's saying done. Serious? She probably saw this and was like, what? How do I get rid of that? I don't know. It's so weird. I'm not second grade. Especially.
Okay. So an asymptote is a line that the graph approaches but does not cross. So let's look at some examples. So typically, when you draw in an asymptote, you'll use a dashed line. So this is an example of an asymptote here. Notice what kind of line is this red dashed line?
It's a horizontal.
Horizontal, right? So we would call this guy a horizontal asymptote. Let's look at another one. If I look at this asymptote, what kind of line is that?
Vertical.
So this could be would we call this a vertical asymptote? Are there other kinds? Seems like it, considering Mr. Kulik's going and drawing some stuff in. What kind of line is this?
I mean that.
Diagonal. So you might call this a diagonal asymptote. Or the more common way to call this would be like an oblique asymptote, I think is the more common verbiage. Although if you called it a diagonal asymptote, nobody's going to look at you funny. Everybody's okay with this? All right.
Done. Done? It's fine. That's so rude. It's not. The other day you asked me to do something. I haven't seen them. Done.
Okay. Sure. So here we're asked to find the asymptotes for this function f of x, and then confirm that they're asymptotes with the table. So to find the asymptotes, I would start by looking at the graph. I'm just going to read the values from my calculator, ideally. So I'll go to the y equals, clear that stuff out. Here, it's going to be very important that you're using that fraction command that I gave you, or you're using a parenthesis around the entire numerator and also the entire denominator. So if I press alpha y equals and pick option 1, okay. And then I'm going to just go ahead and zoom standard that again, since I changed my window for the previous problem.
What the?
How do I make it what? Alpha y equals, pick option 1.
But it didn't work
No.
for the whole.
Is everybody okay with what we're looking at here? So I see one vertical asymptote looks like it's happening right here. That looks like -1 to -3. Everybody agree with that? So let's record that. And then I see another vertical asymptote kind of right here. Vertical. That looks like x equals 1. You guys agree with that? Okay. And then, are there any other asymptotes? Well, it certainly looks like there might be a horizontal one here. See that this end is flattening out and this end is flattening out? Yeah, here's the thing about those ones. We're not going to worry about them. If it looks like an asymptote at the ends, we're still going to count it as an asymptote for now. When we talk about rational functions later on in second semester, we'll be a little bit more detailed there. And that's something ideally you would have talked about already in your Algebra 2 class. But since we haven't, we're just going to go for right now and still count that kind of thing. Is that okay? So if I look at that, it looks like it's flattening out at what y value? Seems like 1 to me. You guys agree with that? Okay. So these guys were VAs and this was an HA. All right. So to check this, or to confirm with a table, what I'm going to do is I'm going to check what's going on with my function as my x values are getting very close to -3 from before -3 and then after -3. So before -3, maybe I'll look at, let's make it xy. We'd use maybe -3.1, -3.01, and -3.001. And then if I'm looking after -3, maybe I do -2.9, -2.99, and -2.999. And I'm just going to kind of see what's happening to the y coordinate there. How would I get the y coordinate? Yeah, what am I doing specifically though?
Table.
I'm plugging those values of x into my function, right? That looks like kind of a hassle though, doesn't it? Is there an easy way for the calculator to do this? Yeah. So I'm going to exit back out to the main screen by pressing second in the mode command. And then what I'm going to do is I'm going to press the vars button, which is right here kind of below the down arrow. I'm going to scroll over to the yvars tab. And then from the function option, I'm going to select where I typed in the equation that we just graphed, which in my case was y1. I assume everybody put theirs in y1.
Yeah.
And then I'm going to do y1 of negative 3.1, like a function notation, and press enter. What does the error say?
I clicked out of it, but it looks like it did the same thing.
Right, but what did the error say? I need that to be able to tell you what you did wrong. Yes, sir.
Whatever arrow got
You
you.
know, wait there.
Yeah.
It just says error. I clicked out of the notification.
Syntax.
Okay.
So
So my guess is that you did the subtraction symbol instead of the negative sign.
yep.
See how if you tell me what the kind of error it is, I can almost assuredly tell you what you did wrong. This is what you get when you've been a math teacher for 15 years or whatever. You've seen everything that a kid could possibly do wrong on a problem. It's like, oh, that's probably what you did. Anyways, so I would write that number down over here. And now, rather than going back through all those menus to retrieve that, I'm going to press second and enter. That'll just give me the last thing I typed in. And I'll just use my back arrow to go back and change that to 3.01 or negative 3.01. So second and enter recovers the last thing I typed into my calculator, and I can just go back and edit that. So I don't have to hunt through all those menus all over again. Okay. If I look at this, what am I noticing is happening to those values of y? And by bigger, you mean smaller, right? More negative. So we're seeing that y is heading towards negative infinity because they just keep getting smaller and smaller the closer and closer we're getting. Did you guys kind of see that? Let's check the other side. Something weird just happened, and like my ears popped and now they're ringing. It's like the pressure changed all of a sudden or something. It's very strange. Of course. Oops, forgot my negative sign. So I got 8.4 and then 75-ish. And then 750-ish. What are we noticing here?
You're going to positive.
Sure seems like it.
Bless you.
Yep. Somebody's got a timer going off or something. Maybe it's across the hall.
What?
That's all
I hear it too.
Not you.
No, I heard it.
The beep, 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 beep.
No.
Yeah, I hear it.
You hear it?
Yeah.
Okay.
It's like faint.
Yeah. Is it your phone?
I don't know, but I better.
No, it's like quiet.
Oh, I think it was because it just stopped when you. Yeah.
I did not.
Maybe at least I'm not crazy because at least someone else heard it. It was quiet though. Yeah.
I could not hear.
All right.
Sound like Miss Winslow.
Oh, maybe those are.
So this is what I need to see in order to confirm that this is a vertical asymptote. As I get close to that value from either side, the function is heading towards either positive or negative infinity. I hear it again. I think it's across the hall. I think that Miss Kroll's got a timer on for whatever they're doing. I'll move it if you need to. It's on the calculator screen also. That's okay. So now we're looking as x approaches 1. So I'm going to do the same thing. We're going to start from less than 1 and get close, and then start from above 1 and get closer. And we're doing the same thing. And we're just going to, again, we're hoping that these values are heading off towards either positive or negative infinity.
There are more than 1 minute. We're on 3.
So that looks pretty good, heading towards negative infinity, right, you guys?
And after 1, you've already done.
And we'll just... And again, just getting closer and closer to 1. And we're shooting off towards positive infinity. So this is what confirmation with a table kind of looks like. It's a little bit tedious, but I'll tell you what it's better than is plugging all those numbers in by hand. Right? Now, if I want to do the horizontal asymptote, is my table going to be set up the same way where we're just going to get close to 1 from either direction?
We're gonna have the points.
Yeah, we're looking for the y's to head to 1, but the x's need to be getting progressively very, very big and then also very, very small. So maybe we'll do negative 10, negative 100, and then negative 1,000, and then positive 10, positive 100, and positive 1,000. And we'll do the same thing. Again, we're hoping that to see our y coordinate heading towards 1. Oops. Let's try that again. Notice how I got this kooky fraction here. I don't really want that. I'd prefer a decimal. So I'm going to press the math button and select the DEC option afterwards. That'll ensure that it represents that as a decimal for me. And then if I press second and the delete key, it allows me to like insert a number without overwriting anything. Do you not know all these cool shortcuts? And what do we look like our y values heading towards?
Slowly but surely.
Yeah, heading towards 1, which is what we were hoping for. I spoke too soon about my pen wanting to be cooperative here. There it goes. Okay. And then I can do the same thing with the other 3. How do you guys feel about this, other than being kind of irritating because it's just like a lot of calculator work? Fairly easy to do though, right? Yes, sir.
Why do we choose negative 10, negative 5?
Completely arbitrary. So I just picked stuff that was like, yeah. So I just, there's nothing magic about those numbers. They're just easy things to type into my calculator. I just want to be getting like progressively a lot bigger from step to step. But you could have done like 8, 232, 576, 1019, or like the numbers don't really matter. It's just like getting progressively bigger or smaller. You know what I mean? So like, I just did this because those numbers are clean looking. They're pleasing to the eye. All right, this feels like a good place to stop rather than starting in, because we had only a few more minutes, right? Like 5 minutes or whatever.
Yeah.
This is a good stopping point. At this point, you guys should be able to do up to 24. So I think that makes 13 to 24 is the new stuff, I think. Just to add some clarity, because I don't think I've done a very good